All right, today we're going to do cones. This is a cone, vertex, lateral surface, and base. A cone is a three-dimensional figure that consists of a circular base and a curved lateral surface that connects the base to a single point not in the plane of the base, called the vertex. Here's the example. Vertex is right here. H is for height. There's that R for radius. Base is a circle. Lateral surface. Think of an ice cream cone. Boop. Words we've already seen before. Altitude, again, is that height. Okay, if you want to pause the video, write that down. It's totally up to you. But going back, again, right angle, height. It's also the axes. But that idea of obliqueness, I guess. An oblique cone, see now, the altitude has shifted. It's kinked over. I'm trying to think of stuff that's like that. Really not maybe a spotlight. I mean, can you see a spotlight being? You see that cone of light coming from it when you're watching a play or something. I don't know. Anyway, just thoughts. Boop. Again, this idea of a cylinder and a cone relate. If you have a cone and a cylinder with the same base, and same height, how many cones do you think it would take to fill up the cylinder? Unfortunately, this is one of those things we didn't get to do this year, but I sometimes take the class to Dairy Queen, and we get not one, not two, but 3 ice cream cones and fit them in a sundae lid. And it's always pretty neat because we'll get really close to the top, and then students like, it ain't gonna fit, and then it fits, and then we get that the idea that 3 cones make a cylinder. Now, since 3 cones make 1 cylinder, that's that 3-to-1 ratio. But for our formula, we're going to focus in on this cone here. So how many cones? 3 to the 1 cylinder. So it's like we take the cylinder, divide by a tree, flip the ratio, 1/3. 1/3 of a cylinder is the idea here. 1/3 of the cylinder. So I'm trying to make circles. Equals the volume of a cone. The volume of a cone, because we're talking about volumes. Boop. So volume of a cone, the volume V of a cone with base area B, height H, and the radius R is given by volume 1/3 big base times height. Remember, this is base area. Our base is a circle, so we replace the big B with pi r squared, because that is the formula, area formula for the circle. That's what the cone is sitting on, a circle. I know it looks like an oval for your picture, but you got to think 3D. It's a circle. Okay. Excellent. Boop. So, find the volume to the cone to the right. Again, this will be a perfect time for you to pause the video and try it out yourself. Just to remind you, it's going to be 1/3 base times height. Remember, the base is a circle, so it's 1/3 pi r squared h. Okay, so 8 is going to be your radius, but don't get confused. This is our height because it intersects the base at a 90-degree. So this is our height. The 17 is our lateral surface length. We don't need it. So plug in what you know. Boom. 15 height, 8 radius. Grab your handy dandy calculator and plug it in like you see it. Which I can't emphasize how much I think it's so cool these Casios do this. We'll put pi. If this doesn't work, then we need to put like a time symbol here, but we'll try it out. So, plug it in just like you see it. Again, if it doesn't work, it's because I probably need to put a times in between that pi there, but it worked. So 320 pi. 320 pi. Again, exact answer. So if I want a decimal, I need to hit the SD button. Boop. 9 rounds a 0 to a 1. Again, I'm just doing 2 decimals. Read the directions, figure out what you need to round to. But for this example, 9 rounds a 0 to a 1, so 31. So 1005.31. Again, cubed units. Okay, cubed is volume. Squared is area. Boop. That's about it. Again, I'm trying to make these videos short and sweet, but you know, ice cream cone, again, you can pause the video, try it out. Answer's right there, but go ahead and pause the video. All right. Now remember, the question says, how much larger is the sugar cone? Oh, someone just pulled into my house. I'm scared. Boop. Should have got that. Remember, difference. This 1 is not a 1. This 1 is supposed to be a pi symbol. Okay? Boop. All right, let's get into spheres. Spheres. A sphere is a set of all points in space that are the same distance, r, from a given point known as the center of the sphere. How is this different from the definition of a circle? How is it the same? Again, here's the center. All of these are the radius. All of them equal distance. The sphere, exact same thing, but it's in 3 dimensions. If you decide to extend your mathematical knowledge, not only are you dealing with x, y, z, x, y for this one incorporates x, y, z. Whoops. There we go. And let's see if I remember. I feel like this is y. I feel like they make this z, and this is x. I remember it's switching. I mean, to me, it'd make more sense to add the z right here. But I think it's about like if you were to lay it down or something. I don't know. I know z's thrown in there to make the 3D part of it, but for the life of me, I don't remember how to orient it according to textbooks. Anyway, the volume formula is right here. For sphere, it's 4/3 pi r cubed. So for this one, you care more about just the radius. Pause the video and write that down. Again, try to make this video short. Going for 10 minutes. We're at 8 minutes and 17, 18, 19 seconds. Let's see if we can do this. Find the volume for the sphere on the right. Boom, 11 inches. So, volume, 4/3 pi r cubed. Remember, cubed comes from the idea that it's the volume. So, radius is 11. We just plug that in. So, 4/3 pi 11 cubed. Let's get the calculator. So 4, 3, pi. Let's see, 11 cubed. Boop. Yeesh. 5,324. 5,324 over tree. Pi was a tree. Indeed, it was tree. Again, exact answer. Decimal, hit the SD button. Boop. 9 rounds that 7 to an 8. Again, I'm rounding 2 decimals. Follow directions. 9 rounds that to an 8, so 28. So 5,575. 5,575 point. Oh, was it 28? It was 28. Inches cubed. Skadoosh. Okay, again, follow directions. I might ask exact. I might ask for the decimal. Don't forget. And really, that's all there is to it. See if there's a hard one. Again, this is the diameter. So take half of that to get 6 inches, and that is your radius. Okay? But other than that, you're just plugging this in. Obviously, the hemisphere, we'll do... here, we'll do this one real quick. I'm trying to keep this video short. Again, following the formula, radius cubed. You just plug in the radius. Just find the radius, plug it in. Okay? Real quick, I think I'm going to go straight to the decimal answer. And look, it's already in my calculator. I'm just going to hit back and change that to a 3. Boom. 36 pi. 113 point... I'll make it round up 10. 100... Ah, geez, I already forgot. 113.10 millimeters cubed. Done deal. Okay. Fun fact, hemispheres. We, in case you didn't know, live in the northern hemisphere. Okay. So let's say we have a dome. They're giving us a diameter of 114 feet. We need the radius, so 142 divided by 2 would be 71 feet. This is our radius. Plug that into the formula. There we go. Our radius is 71. And then just cube it. Boop. Again, just going to go back and change this to a 71. Up, boop, 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 boop. There we go. 71. Boop. Yeesh. All right. This is where I'm going to drag this off the screen so I can see it, but you can't. That way I can write this number down. 499,214. So what do we got here? 1,499,214 and 10 feet cubed. Now, fun fact. They want the hemisphere. We didn't incorporate the hemisphere. We incorporated the whole sphere. So hemisphere is half of it. So use that logic. We're just going to divide this by 2. So let me drag this back over. And we're going to divide by 2. Right, we got a fraction. We'll just keep it decimal. Again, I'm going to drag this off so I can copy it down. Too many numbers for me to remember. It'd be like that. 749,607. Rounding 0.05. That's too many points right there. Didn't even realize I put that point there. Boop. 0.05 feet cubed. So what is that? 749,607 and 0.05 feet cubed is our answer. Again, in the interest of keeping this short, I think that's it. I'm trying to keep it under 15 minutes. Boop, beep, blam. Oh, hope you didn't see that. The Earth question. I love going over this one about how big the Earth is. It's really stinking big compared to us. And again, here's some fun facts, math-wise. 264 billion cubic miles. That is so huge. And to think that Jupiter is bigger, and then the sun is bigger than that. Creepy, I know. Thank goodness for gravity. I still don't believe this. They're talking like, you're going to have to ask a science teacher or something, but how fast the Earth is spinning is like really, really fast. We just don't know it because we're used to it, and I can't comprehend that. I cannot comprehend that the Earth is spinning that fast, and and we just don't know it. I just can't. I can't accept that right now. Doop 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 doop. All right, that's it. Boop boop bam, boom. Pow. I wonder if the counter is in sync with me. 15. I mean, I got 14, 55, 56, 57. I'm gonna stop it at 15. Right about